In this question, we'll write symbols for various isotopes. In part A, we are given an ion with 1 plus charge, an atomic number of 55, and a mass number of 133. The first thing to do is locate this element in the periodic table. We'll look under element number 55, because that's the atomic number. On the periodic table, we see that element number 55 is located here in the lower left corner. This element is cesium with the symbol Cs. So we'll begin by writing Cs, the symbol for the element, and in the lower left location, we will write the atomic number 55. Number 2, we'll find the mass of this isotope. Thankfully, we are given the mass here is 133. We write this in the upper left location. Number 3, we find the charge of the ion. We are also told that the ion has a 1 plus charge. Now we could write 1 plus or plus, but either way, we write it in the upper right corner. It's okay to say either plus, or you can precede this with 1 plus as well. This is the completed symbol for cesium 1 plus with a mass of 133 and an atomic number of 55. Next, let's try part B. This time we aren't given the charge or the mass number, but instead we are given 53 protons, 54 electrons, and 74 neutrons. Number 1, once again, let's use the number of protons to locate the element in the periodic table. Because we have 53 protons, we'll go straight to the periodic table and look for element number 53. Element number 53 is located on the lower right side, here in this black box. The element is iodine, capital I. We'll begin by writing that. The atomic number is just the number of protons, or 53. Number 2, we'll try to find the mass. We're not given the mass, but we can find it by taking the number of protons plus the number of neutrons. Our protons were 53, and then our neutrons were 74. If we add these together, we'll get 127, and this will go in the upper left section. Step 3, let's find the charge. To calculate the charge, we take our protons minus our electrons. Now we have 53 protons, and we subtract 54 electrons. Protons will be positive, and electrons will be negative. Together, this makes -1. We place this in the upper right section where the charge goes. We can either say minus, or we can also say 1 minus. Either one is fine. This is the completed symbol for iodine 1 minus. In this question, given the symbols for the isotopes, we can find the number of protons, neutrons, and electrons. We'll begin with silver, mass 109, atomic number 47. Now, 47 is the atomic number. This automatically gives us our number of protons. So right now we can say the protons are 47. Now the mass is 109. Now let's recall that mass is protons plus neutrons. So we can set up an equation that says P for protons plus N for neutrons is 109. But we already know that protons are 47, and so we replace the p with the number 47. Add the neutrons, and get 109. Now, we need to solve for the neutrons, so we subtract 47 from both sides. 47 minus 47 will cancel, and n will be 109 minus 47, which is 62. Now to find the electrons, we use the charge. However, there is no charge written, so we'll say that the charge is 0. So our charge will be the protons minus the electrons. So now we'll write this as an equation. Our charge was 0. This will equal our protons, which were 47, and our electrons, which we don't know. We'll put the letter E for electrons. Now, all we need to do is add E to both sides. On the right side, the negative E and the positive E will cancel out. This gives us E on the left equals 47. Notice that this is the same as the protons. This will be the case as long as there's no charge. Now let's try nitrogen. We can see on the lower left, the atomic number is 7. This will give us 7 protons. Now our mass is equal to protons plus neutrons. We are given a mass of 15, so we'll put that in the position where mass is. The protons are 7. We'll put that in the position for P. And the neutrons we don't know. To solve this, we subtract 7 from both sides. This will give us that our neutrons are equal to 15 minus 7. That's 8. Now remember that our charge is our protons minus electrons. As we look to the upper right corner, we see a negative sign. If you see a sign with no number, then the number is automatically 1. Therefore, we'll say the charge is negative 1. Now our protons are 7. And the electrons we don't know, we'll leave that as E. And let's solve for E. First, let's move the 7 to the left side. We'll subtract 7 from both sides. On the left, this will give us negative 1 and negative 7, which is negative 8. This will equal negative E, because the 7 and the minus 7 will cancel. Now, all we need to do is get rid of both of these negative signs by dividing both sides by negative 1. Negative 8 divided by negative 1 gives us an electron count of 8. And so this is how we find the protons, neutrons, and electrons for both of these isotopes.